Hi, I'm Michael von Schenk.
My name is Evi.
Gabriel Gerardo Urdaneta Herrera.
So for our inputs for the project, we're going to have a 1.1 volt AC source, which is basically what we found online to be an average of about 2.2 volts peak to peak. And that's what we found online, is that that's the average for a typical iPhone cell phone. That's what we're going to use to drive this in our final term project. We also are going to test it through a frequency range based off of music, because we're trying to do essentially a bass boost. And the range of music is going to be anywhere from 20 hertz to 20 kilohertz. Our output, our gain should be less than 2.6 for all frequencies. And for any frequency greater than 100 hertz, we want a gain of greater than 1. We want to amplify the bass. For any frequency that's less than 100 hertz, also less than, 628 radians per second, is we're going to try and dip down to a gain of less than 0.1, especially when it hits about the 1600 mark for radians per second. Our relationship, our filter is supposed to have a cutoff frequency of the 100 hertz, 628 radians per second. It's supposed to pass all frequencies below 100 hertz with a gain greater than 1, but below 2.6.
And here is the simulation where we have the 1.1 volt input, which is the input of, should be the output of an auxiliary port of a phone. And these are the resistors and capacitors that we calculated. That's the whole part, but we are measuring right there. And if we run it, we're going from 220 hertz to 20,000 hertz, which is the spectrum of audible music, or that's what music usually runs between. And this is what we get as the output, which is 2.28, and it has this little gain here, which from the capacitors. And then at 100 hertz, we have 0.1 volts, or 0.9 volts, which is almost a volt. And then at 200 hertz, we have 0.18, which is almost 2, which is getting pretty close to what we want. And after that, it just keeps going down, 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 which is what we want. So we have a little bit extra noise coming in above, so 100, 150 to 200, but it's such a low amplitude that it won't cause any distortion from that. And the 2.2 shows that we have a gain of 2 from the whole thing, since we have the 1.1 voltage input. And that is our third order low pass Butterworth filter simulation.
So right here we have our circuit, which is a third order low pass Butterworth filter. We have the input from the function generator coming in here and going into the 3 resistors and capacitors and to the op amp. And we also have the R1 and R2 over here, which does the amplification.
Okay, so here we have the signal generator. The frequency is 10 hertz, and we can see that the output is 592 millivolts. Then if we take it to 20 hertz, it stays in 624 millivolts. Okay, so here we set the frequency to 10 hertz, and we can see that the output voltage is 584 millivolts. Now we go to 20 hertz, and we see that the output voltage is gonna be 632 millivolts. If we go to 30 hertz, the output is going to be 600 millivolts. Now we go to 40 hertz. The output is 608 millivolts. Now we go to 50 hertz. Whoa. 50 hertz. and the output now is 644 millivolts. Now we set it to 60 hertz, and the output is 644 millivolts. Now we go to 70 hertz, and the output is 644 millivolts. Now we go to 100 hertz, and the output stays in 600 millivolts. Now we go to 90 hertz. The output is 644 millivolts. We go to 100 hertz, and the output is 648 millivolts. Now we go to 150 hertz. The output is 628 millivolts. We go to 200 hertz. The output has gone lower to 600 millivolts. Now we take it to 300 hertz. The output decreased to 368 millivolts. Now we take it to 400 hertz. It's getting smaller to 138 millivolts. Now let's take it to 1000 hertz. The output voltage is 18.2 millivolt, which is really small compared to the previous value. Now let's go to 1500 hertz. And that is 3 millivolts. So if we go to 10,000, it stays around 3 millivolts. So as you have seen, this circuit, as the frequency increase, the output voltage will decrease, and we see that it's filtering all high frequencies above 100 hertz. Thank you.